All right, today's lab we are going to do a qualitative, not quantitative, a qualitative analysis of a series circuit. Now a series circuit is a circuit where all these circuit elements go in a straight row. For example, I have a bulb here, connected by another bulb, a switch, and a battery. Now, we turn on the switch and the lights come on. Of course, they're pretty dim, right? But they're on. All right. So that's a series circuit. Everything goes in one straight line. We don't have anything that branches off in any other direction. So let's take a look at how we actually do something qualitative versus quantitative. Let's just look at one single light bulb. So for a single bulb, we're going to use two batteries. All right, and then a switch. I turn on the switch. Whoop. Oh, this battery is out of the socket. So the socket's not working very well. So light goes on when we turn on the switch, and so forth. Now you see it's much brighter because I have two batteries hooked up this time versus one battery on the last setup. So let's take a look at what we're going to do. I'm going to replace the switch with this dimmer. We're not going to use the dimmer in today's lab, but I'm just using this for an example. So if we look at that, we can look at the amount of light that's given off by the bulb. All right? So the brighter the light, the more power. So if I turn this, I'm reducing the power to the light. All right? If you can see that on the video, there's still a little bit of glow in the filament. All right? But that's much, much less light than this was. All right? So we would say that there's less power in this situation. So we're going to look at different arrangements of light and assess what the power level is for each of those types of arrangements. Once we know the power, well, we know that power is equal to current times voltage. We can assess whether the voltage changed to make it have less power or whether the current changed to make it have more or less power. All right, so that's today's lab. So a couple things we want to do is, one, make sure that you have both of your batteries in the right direction. So plus and plus are on this side, so you should be minus, plus goes into the minus end of the other battery, and plus. All right, because what's this battery do? This is a 1.5 volt battery. This adds 1.5 volts of energy from here to here. Then it adds another 1.5 volts of energy from there to there. So that gives us a total of 3 volts. All right, so then we'll have a bulb and a switch. So when you're not making observations, just turn the switch off so we don't burn up the batteries or use up the batteries. All right, so first part of the lab, you'll use one light, throw the switch, take the switch back off, right? Answer a few questions. Next, what we're going to do is, for the second part, we need two in series. So to do two in series, we just put these in a row, and now they're in series. So you can go through and answer the questions and for the configuration in series. And then lastly, we're going to use 3 in series. All right. Three of them in series. So there we go. 1, 2, 3 in series. Again, go through, answer the questions. Now, some of the questions are going to ask or you will be asked, are how do the bulbs compare individually? Like, are they the same brightness relatively? There's one really bright and two are really dim. All right. And then the other thing is we're going to look at the total amount of brightness of like all three bulbs. All right. And the total amount of brightness of all two bulbs. All right. And the total amount of brightness of just one bulb. Right. So we can do just one bulb. All right. And so kind of make a mental note of how much light that's giving off, and then compare that to when we have two bulbs and three bulbs. So if the total amount of light goes up, that means our power went up. If the total amount of light goes down, that means our power goes down. So that concludes what we're going to do for today's lab.